Hi, the purpose of this video is simply for those of you that are going to be using the test site for this class for ME313. This is the site at thermofluids.net. That's fine to use for this class, but there's a couple things I want to point out that it'll be important for if you're using this during our chapter tests. So, for example, I'll just show you what I expect for you to do on a problem. So let's imagine that this was the exam problem we had. We have steam, has this initial pressure and quality. It's got a spring connected to it. It's going to have an initial volume of 2 cubic meters. Some heat's added. It goes up to 5 cubic meters, a new pressure of 225, and it wants to know how much heat is transferred and the work produced by the steam. So imagine that was our test problem, and we're going to go and do it in the app here. So. And what we go over, and I'm not going to go too much of this because hopefully you're familiar with it if you're using this for this class, but this would be a generic simple process of a phase change. And so I'm going to go over into the application. So now from the application, we're going to go ahead and enter our initial state. So if we remember, let's go back and look at what our initial state was. We were at 75 kPa and 8%. So I'm going to go ahead and go back to that. And I was at... my pressure was 75 and my quality was 8%. Oops, 0.8. And we come back here again, and we were also at an initial volume of 2 cubic meters. So I'm going to go ahead and set my volume there at 2 cubic meters. And so if I have everything specified, looks like I do, calculate here all my initial conditions. So let's go ahead and click over to state 2, and let's look at remind ourselves what state 2 was. The volume is 5 cubic meters and the pressure is 225. Okay, so our pressure is now 225. Our volume is now 5. And we've only got one intensive variable because that's the extensive volume. So we need to go ahead and say this is a closed system. So the mass is equal to the same as M1. So there we go. It looks like our second state is completely specified. So now we're going to go into our process panel to account for the fact that we've got this spring. So I'm going over here. We're going from state 1 to state 2. And we're going to have it calculate what Q is. But we need to go ahead and tell it that it's doing that, essentially the boundary work for the spring. So what that is. And so this is a linear spring is what the problem says. So that would be P1 plus P2 times vol2 minus vol1 over 2, so it's sort of a trapezoid. So if I go ahead and calculate that, so the boundary work is 450 kilojoules, and the heat transfer is 12,750. All right, so we've solved the problem. Now here's what you need to do if you're submitting this to me as a test problem, is you need to come over to the I/O panel, go ahead and click Super Calculate, and give yourself this panel that I'm showing right over here. And this is what you need to go ahead and do is copy and paste this right over here and submit that in place of the EES file. That way I can go ahead and reproduce your work. And it'll be pretty important when we go to problems that have multiple states. Some of our Rankine states will have 10 or 12 states, and it'll be the only way that I can verify what you've done. So if you have any questions about that, let me know. Good luck.